Hi, welcome back. So let us now continue our discussion and discuss the what we call velocity. So velocity here is simply when this particle moves along this straight line or moves along this path during some time. So there is now a time inclusion. So the time is included. So if the particle moves along this line for some time, that is what we call velocity. So if the particle moves through a displacement, delta s, during the time interval, delta t, the average velocity of the particle can be defined as the velocity average is equal to delta s over delta t. Okay, if the particle moves through a displacement delta s, so this particle moves along straight path with the displacement delta s during time interval, so let's say this is time 0 up to 1 second, 2 seconds, the particle moves along from this to this. After 3 seconds, the particle moves along up to this point. So it has some interval delta t. So the average velocity of the particle can be defined by this equation. So V average is equal to the change in position over change in time. So this is the displacement over change in time. Okay, but if we take smaller and smaller values of delta t and delta s, smaller and smaller values of delta t, the magnitude of delta s becomes smaller and smaller also. Okay, and consequently we can now compute its what we call instantaneous velocity. Okay, so for our instantaneous velocity, we are now computing the limit of delta t as it approaches 0, meaning if we take the smaller and smaller values of delta t here. Okay, so as the delta t approaches 0, delta s over delta t. Okay, the limit of delta s over delta t as delta t approaches 0. So this is now our for equation B for instantaneous velocity. Okay. Or if we use this is in a algebraic form, but if we use our calculus, we can define this as the ds over dt. Okay, since your delta t here or your time here is always positive, since you always count your time from 0 up to increasing values, and you don't use time like say negative 2 minutes. Now we don't use that. So since dt is always positive, the sign that we use to define the sense of this velocity is the same as the sign that we are going to derive from delta s or ds. Okay, so whatever the sign of your displacement ds will be the sign of your velocity. Okay, that is the difference. Since position is a velocity, therefore the displacement with the change in position can carry out its direction and magnitude. That's why it is also a vector. And since it is also a vector, the change in position over change in time of velocity is also called a vector quantity. Okay, since it has the both magnitude, so what will be the magnitude of this velocity? Maybe it is in terms of since let's say positive 10 kilometer per hour or feet per second. What else? Inch per day, and many other. So once again, delta s in terms of length or in your position, which is the Usual unit is in terms of length, kilometer, feet, inches, etc. Delta t is your time, change in time value. So the unit is usually expressed as hours, second, minutes, day, and others. But this magnitude here is what we call the speed. So the magnitude of the velocity is what we call the speed. What is the speed of your car? Speed of the car is only 20 km per hour. So it's a very low speed, or mabagal is speed of the car. But when we say velocity, for example, the velocity of the car is positive 20 km per hour, since it is going to the right direction, or negative 20 km per hour if it is going to this direction. Or maybe you say that the velocity is 20 miles per hour going to the north. So if the velocity is 20 km per hour going to the north, then the speed of that car is 20 km per hour. Okay. So that is the main difference between the velocity and speed. Speed is only the magnitude of the velocity, while when we say velocity, it has both the magnitude and the direction, since the change in position or displacement and the position is a vector quantity. So it carried out the direction given by this delta S. So on our next video, we will tackle regarding the acceleration. But before that, let us review what we have discussed here. So we say that the velocity, once again, is the movement of the particle through the displacement S along time t. So it is the change of position along some time t. Okay. So velocity is position over time. Once again, velocity is position over time. Okay. So that's all. See you on our next video.